Good morning, everyone. So, welcome to my YouTube channel, Maths Doctor. So, today we are going to see another important question. We have to find an example of a group. Give an example of the group in which question number one is that the inner automorphisms corresponding to any two elements are the same. Second one, the inner automorphisms corresponding to no elements are the same. It means we have two questions, and in each one we have to find a group which satisfy the given criteria. Okay. So we have to find the example of two groups which satisfy the given criteria. Okay. So let's see how we will solve it. Solution. First, we have to find an example of a group in which any two inner automorphisms corresponding to any two elements are the same. It means I will take identity, and if I will take any element which is A belongs to G, such that A not equal to E, then what is the inner automorphism corresponding to identity? It is always an identity map. Okay. And it is given that inner automorphisms corresponding to any two elements are the same. So it means FA will also be same. So actually, what does it mean? It means that inner for all A belongs to G, A not to E, because inner automorphism and corresponding to any two elements is the same. We know corresponding to identity element, the inner automorphism is identity map. But we are taking A, so it will be equal to I as given in the question. So what we have, inner automorphism is nothing but contain identity map. So, okay. So we know that inner automorphism of a group is always isomorphic to G quotient Z, center of G. Okay. This is identity map. This is identity map. Sorry, it contains only identity element. So this is isomorphic to G by Z. So when quotient is nothing but contains only one element, that is identity element, in that case, center is equal to G. So here G is quotient by center, and it is isomorphic to a group having only one element. A group having only one element means it contains only one element. So what does it mean? In this case, this is possible only the quotient, the group, the subgroup by which we are taking quotient is equal to whole group. Okay. So we have what we have, ZG equal to G. Okay. And we know that ZG equal to G is only if and only if G is abelian. Okay. This is possible if and only if G is abelian. So this implies G is abelian. G is abelian. So this implies G is abelian. So if we take any abelian group, our question will be done. So we are taking this group. So we are taking this group, G is equal to Z. So we are taking this group, set of integers. Or we can take this one. So I'm writing that one. So we can take this group also. So we are taking 1 minus 1, I minus I. Okay. So I square is minus 1. Iota. I is iota. Okay. Then G is example of required group. Okay. because G is abelian with respect to multiplication operator. Now, second one. So we know that we have to find an example of a group in which corresponding to any two distinct element in an automorph corresponding in an automorphism are distinct. So it means we have to show we have this relation. Fk is not equal to Fb for any AB belongs to G, A not equal to B. Okay. Now, obviously, for any element we have isomorphism always. So in this case, what we have, the order inner automorphism will be isomorphic to G because every element have a distinct inner automorphism. So what does it mean? It means inner automorphism is isomorphic to group G. Okay. So, but we know that inner automorphism is nothing but what is this? This is isomorphic to G by ZG because inner automorphism of G is isomorphic to by ZG. So what does it mean? If we will put value of G by ZG, it will be isomorphic to G. Okay. Now, G quotient ZG is isomorphic to G. When it is possible, if and only ZG equal to if and only if ZG is equal to identity L, contains only identity element. So when it is possible, so we have to find an example of a group in which the center of a group G is nothing but contains only identity. So what is the example? We know that ZSN is equal to contains only identity element for all n greater than equal to 3. So we can take n is equal to 3. So S3 G is equal to S3 is the required example of group. Okay. So today's question up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's question. Thank you.